Hey everyone from Colegio Bilingüe Cuscatán, welcome! Today, Mr. Paredes and I are going to break down everything you need to know about parallel and perpendicular lines. So here's our game plan. First, we'll quickly go over our goals. Then, we're going to dig into what makes lines parallel and uncover the secret to perpendicular lines. After that, we'll walk through an example together, and then it's your turn to put it all to the test with some practice. Okay, let's dive right in. The goal here isn't just about memorizing rules, it's about getting you so comfortable with this stuff that you can glance at any two linear equations and just know their relationship. And even better, you'll be able to build your own. So, what's success look like by the end of this? Well, you'll be able to define parallel and perpendicular lines just by their slopes. You'll be able to find the equation of a line that's parallel to another one, and you'll be able to do the same for a perpendicular line. Basically, you'll be able to look at any two lines and say for sure if they're parallel, perpendicular, or neither. All right, first up, parallel lines. And this might seem kind of complex, but trust me, there's one really simple rule that they never ever break. So just take a look at these lines. What do you notice? They've got the exact same steepness, right? The same tilt. They're like two cars in different lanes going the exact same speed. They'll run alongside each other forever, but never, ever cross paths. And that brings us to the big secret, the one thing you have to remember. Parallel lines have the exact same slope. That's it. It's the whole key. If one line has a slope of 5, any line parallel to it also has a slope of 5. Simple as that. Okay, so how do we actually find a parallel line? It's a pretty straightforward process. First, you just need to identify the slope of the original line. Easy enough. Then, step 2, you use that same slope for your new line. From there, you just plug in that new slope and the point you've been given into y equals mx plus b. That lets you solve for b, the new y-intercept. And boom, you just write out your final equation. Let's make this real with an example. Say we need to find a line that's parallel to y equals 2x plus 3, and it has to pass through the point 4, negative 2. Well, the slope of our original line is 2, right? So our new line slope is also 2. We plug that 2 and our point into the equation, do a little algebra, and we find our new y-intercept is negative 10. So the final answer, y equals 2x minus 10. See? Same slope, just a different starting point on the y-axis.
All right, now let's switch gears to perpendicular lines. This is where things get really interesting. See, unlike parallel lines, these guys do intersect, but they don't just cross randomly. They meet at a perfect corner. So what's the deal with their slopes? Take a look at these lines meeting at that perfect right angle. What do you see? If one line is sloping up, the other one has to be sloping down to make that sharp corner, right? But it's not just about being positive or negative. There's another piece to the puzzle. And here it is, the secret sauce for perpendicular lines. Their slopes are opposite reciprocals. Now that sounds like a fancy math term, but it's actually super simple. Opposite means you flip the sign. Positive becomes negative, negative becomes positive. And reciprocal just means you flip the fraction upside down. That's it. This little chart makes it super clear. If your original slope is 2, or 2 over 1, the perpendicular slope becomes negative 1 over 2. See? We flip the sign and flip the fraction. Or look at the next one. Negative 3/4 becomes positive 4/3. It's a two-step dance every single time. Flip the sign, flip the fraction.
Okay, theory's great, but let's put it to the test. We're going to look at two lines and decide, are they parallel, perpendicular, or just neither?
Okay, let's check out this problem. We've got line A and line B. Line A is in point slope form, which is awesome, because it just hands us the slope right there. It's negative 3. Line B, though, it's not so friendly. We've got to do a little bit of work. We need to rearrange that equation to get y by itself so we can see the slope. After we do that, we find out the slope for line B is negative 1/3. Now for the moment of truth. We compare the slopes, negative 3 and negative 1/3. Well, they're definitely not the same, so they're not parallel. Are they opposite reciprocals? Well, they're reciprocals, yeah, 3 over 1 and 1 over 3, but they're both negative. For them to be perpendicular, one has to be positive. So since that rule isn't met, these lines are neither. Okay, you've seen how it's done. Now it's your turn to take the wheel. I'm going to throw a problem up on the screen. Go ahead and pause this explainer and see if you can solve it. Ready? Let's do it. Here's your first practice problem.
For line A, you've got 2 points, so you'll need to use the slope formula. For line B, you'll need to get y all by itself again. Find both slopes, compare them, and make the call. Go ahead and hit pause now and give it a shot.
Okay, you back? Let's check the answer. For line A, if you do the math, the slope comes out to 2. For line B, once you rearrange it, the slope is -1/2. So, what have we got? We have 2 and -1/2. They're opposite signs and they're reciprocals. That means these lines are perpendicular. Nicely done.
All right, one more for you. This one's a bit different. We need the equation of a line that's parallel to y equals 4x plus 9, but with a y-intercept of 8. Think about what you need for a line's equation and what the problem gives you. Pause here and jot down your answer.
And we're back. This one was pretty quick, right? Parallel means we steal the slope from the original line, so our new slope is 4. And the problem just gives us the y-intercept, which is 8. So what's the equation? Y equals 4x plus 8. That's it! Awesome job!
So let's boil this all down. If you walk away with just one thing today, make it this. Parallel lines mean the slopes are the same, identical twins. Perpendicular lines mean the slopes are opposite reciprocals. You flip the sign and you flip the fraction. Same slope or flipped and switched slope. That's the core of it. And that just about does it for our breakdown. But here's a final thought for you. How can you use this stuff to describe the world around you? Seriously, as you go about your day, start looking for these lines. You'll see them in streets, in buildings, on tiled floors. They are literally everywhere. It's a cool way to see that this isn't just numbers on a page. It's part of the world we live in. Thanks so much for tuning in.